Weights and biases is a beautiful tool that helps you keep your machine learning experiments organized and ultimately save you time. When I sat down at my computer and logged into Kaggle for the first time, I had no idea how to track what I was doing. But now I know how to remember everything I do with ease. In this video, I'm going to reveal weights and biases key features by walking through a code example. By the end, you'll have what you need to get started as fast as possible. Let's go. Google Colab is the perfect place to showcase weights and biases because it's an online tool. This means you have to log into its website. Let me open up a new tab and go to wandb.ai/myweightsandbiases account. In this video, we're going to be talking about weights and biases models features, but they also have weave features for large language models that you can explore on your own. And this is what weights and biases looks like when you haven't done anything yet. So going back to Google Colab, this is the perfect place because Google Colab and weights and biases are both online tools. So we're going to be sending data from Google Colab to weights and biases, as opposed to from my local computer to weights and biases. This really shows the flexibility of the tool. You can access it from anywhere. Like any real world project, we need to start off with some boilerplate code. So here you'll see some of that, and later on, it'll really make our coding examples a lot simpler and easier to understand. I'm going to go through this really quickly, but you can find all of the code on my GitHub afterwards. Link in the description below. Okay, here we do some standard imports for scikit-learn and PyTorch. We're going to be using the Titanic data, so I'll load that here. Here's a function that cleans the Titanic data for us. This is a wrapper function that lets us optionally choose to clean it or whether to split it into features and labels. This function returns the data as tensors so we can use it in PyTorch. Here is a standard training loop for deep learning and a test loop for deep learning. And that's it for the boilerplate. Weights and biases makes using the tool extremely quick and simple. All we have to do is two things. First, we need to pip install Wandb, weights and biases, and then we just need to log in. Let's run these two cells. When you run the login command, it's going to ask you for your weights and biases API key, which you can get from the link right here. Let me copy that, go back to our code, and paste that into the prompt right here, and click enter. All right, we're now set up. Whenever I sit down on my computer to learn a new tool, I always look for simple examples. I find that they are a great way to wrap my head around the basic features as fast as possible. So that's exactly what we'll do here. This code block here shows a really simple scikit-learn example that uses weights and biases to log some metrics. I'm going to run the code block and then we'll jump back and forth between weights and biases and the code. Now that that has run, let's look at this first code block right here. Basically, every time you want to log something, you're going to call wandb.init. This function is going to create a run, and that run is going to be stored inside of a project. You can store multiple runs inside of a single project so that all of your experiments can be stored in a single place for you to look at and analyze later. So for this run, I've specified the project as simple scikit-learn run. If you run this function and the project doesn't exist yet, it will create it for you. Let's quickly jump over to the UI to see what that looks like. So now that we've done a run, our UI here looks a little bit different. Let's go over to projects and you can see simple scikit-learn run. Let me click into this. And here you'll see our first run. If you don't specify a name for your run, it will randomly generate one. Now let's jump back over to the code. So for this run, I also put some notes, which is just any kind of message that you want to include. And I specified some config parameters. These are any values that you want to remember when you're looking at the run later. So here I'm saying that we're using n estimators of 20 because that's what we're going to use to train our random forest classifier from scikit-learn, and a max depth of 10 because that's also what we're passing into this classifier. And that's all I'm going to do here to start the run. Here I'm going to use some of our boilerplate code to load the Titanic data. Then I'm going to create the random forest classifier and train it. And now here I'm going to call wandb.log to log the accuracy metric. Classifier.score for random forest returns accuracy. And the log function of Wandb takes in a dictionary of metrics to values. And then at the very end, I'm calling wandb.finish to let it know that the run is over. Now that you have an idea of what this code does, let's go explore it more in the UI. So like I said earlier, here's our run, and you can see that it logged an accuracy here of 0.81. You can also go over to this tab to view your runs, and you can click into the run to see more information about it. So you can see underneath the project, simple scikit-learn run. I'm looking at the run smooth wave 1. I can look at the overview for this run. And here's a lot of information about it up here. For example, here's the max depth and n estimators, and over here you can see the accuracy. So now you can start to get the sense about for every run that we do, you can associate different metrics and values with them, so that later you can look back and see what you did. AKA, we're tracking experiments. Let's run a few more. How about we change this to 10 and this to 5. Now I'm gonna run it again. Now let's go back up, change this to 30 and this to 2. And now let's go back over to the UI. Scroll up, go back to runs, and there we go. You can see our 3 runs are here, and now you can see the different accuracies that they gave. You can also click into them and view more information like we saw before. So this one used a max depth of 2 and 30 estimators. Now I want to show you something really cool from the runs tab. I'm going to go back up here and click on runs. So here you can see all our runs, but how do we know which one's the best? Weights and Biases provides these different tools at the top here that allow you to group, organize, and sort your different runs. So let me click on sort and select accuracy. Now you can see at the very top, this is the logistic regression model that performed the best. It had a max depth of 10 and 20 estimators. Next, we're going to look at this for some deep learning scenarios using PyTorch, but I hope you can already see how this is extremely useful for tracking experiments that you do, and then selecting the one that performs the best to deploy to production. Okay, back to the code. So here's a simple PyTorch run. I'm defining some hyperparameters here. I'm going to make a new project called simple PyTorch run. I'm going to give it the name of my run 2. I'm going to track some config information for this run. I'm going to load the data, convert the data to tensors, create a simple PyTorch model, establish our criterion and optimizer, go through the training loop and test loop, train loop and test loop, and then call wandb.finish. Let's run the code. All right, let me quickly run it one more time with some different parameters. How about we do 10 epochs, change the learning rate to this, change the name to 3. I'll pass 32 values for the hidden nodes here. Let's rerun it. And now let's jump over to the UI. Let's go back to projects and select simple PyTorch run that it just created for us. And here are our 2 runs. Ignore this one. This was because I had the train loop instead of the test loop. So for the first run we did, you can see the training loss and test loss. And this is for the second run. It's really nice how they put both of these metrics on the same graphs, so you can really visually see which one's performing better. It looks like my run 3 ended up doing a lot better on the test data, but maybe we started to overfit a little bit at the end here. Tracking metrics like we just saw is amazing, but that's just the start. Weights and Biases can track more things. In each project, Weights and Biases has 2 registries that you can use to track artifacts. And there are 2 main types of artifacts: model artifacts, like logistic regression, and dataset artifacts, like our Titanic data that we cleaned. And then each registry corresponds to a different type of artifact. So there's a data registry and a model registry. Let's first look at how we use the data registry. Like I said earlier, every time you run Weights and Biases, you're going to need to call the init function to create a run. So that's what I'm doing on this line here. It's going to create a new project called Artifacts Registry because that project doesn't exist yet. And I put this job type label in of data loading. You can call this whatever you want, and it's just used to help you group runs. So later, if I'm trying to look at the performance of models, I can ignore this one because it's just loading data. So in order to create an artifact, you first need to save your data locally. So here, I'm going to get some Titanic data that's not cleaned, and I'm not going to split it into the features and labels. And then I'm going to save that as raw titanic.csv. And now I'm going to use Weights and Biases to initiate our first artifact. I'm going to call it raw Titanic, and the type is going to be dataset. Later on, you'll see the model artifacts have a different type. And now I'm going to call the add file function, which will add our CSV of the data to the artifact. And then I'm going to call log artifact to actually send our artifact to Weights and Biases. Whenever you create an artifact, you can add some alias to it to help you organize, sort, and find them. So here I'm calling this one raw because it's just the raw, uncleaned Titanic data. And then I call Weights and Biases.finish. Let's run this. And let's jump over to the UI. Let's go to Projects, Artifacts Registry. I'm going to click on the Run and then go to Artifacts. And here you go. You can see this is our Titanic dataset that we just loaded. Let me go back to Runs and click on Artifacts down here. You can also see the artifacts from this view. So here you can see all of the artifacts in your project, whereas previously we were looking at the artifact for that specific run. Notice here that there's a V0. This is the first version of this dataset. Let's jump back over to the code and see how you can create artifacts with different versions. It was a little bit tricky when I first learned it. So in this code block right here, I'm going to log an artifact for a data set of cleaned Titanic data. And then in the next code block, I'm going to create a new version of the cleaned data. Now let's look at this code a little bit more closely. I'm going to start a new run in the same project as above. So it's not going to create a new project this time. I'm going to get the cleaned data and I'm not going to fill the missing values. We're just going to drop all the rows that are missing values. I'm going to save it to a file and then log the artifact. You'll notice that this command looks a little bit different than the one up here. Up here, we created an artifact, added a file to it, and logged it. But you can do all these 3 steps in one if you'd like. So here I'm specifying the path to the data that we saved, the name of the artifact, the type of dataset, and I'm giving it the alias dropped because we're just dropping the missing values. Let's run this. Now going back to the UI, you can see there's now a clean Titanic dataset. This is the first version and it has these aliases. When we create the next version, you'll notice that latest will now be on the new one because it's the latest. Going back to the code, let's now create that new version. Like I said a minute ago, this was a little bit tricky. As always, we create a run here. And now what you need to do is you need to call run.useArtifact and specify the URL of the previous artifact. So right now version 0 has the alias of latest. So I'm using that here. And the name of it is Clean Titanic. Let's look at the UI really quick. You can see the name is Clean Titanic and it has the alias of latest. Back to the code. So now in order to create a new version, we have to create a new artifact with the same name as the one we already created. So I'm passing in the same name and I'm calling the variable artifact next version. Here, I'm getting some new data, but this time I am filling in the missing values with the mean value for those features that we're missing. I'm going to save that to a file. I'm going to add that to our new artifact version, and then I'm going to log our new artifact, and that's it. So the tricky thing was really that we needed to call use artifact and then create a new artifact with the same name as the one we're using. Now let's run this code. And now let's go to the UI, refresh the page. Open this and you can see here's our new version that now has the latest tag. Let's jump back over the code. You might be wondering what this commented out code is right here. Instead of creating a new data set that you add to the artifact, you could download the old artifact that we're using, old artifact, old, read that in using pandas, update it, and then add that to the new version instead of creating a whole new data set that I did here. So we just looked at the dataset artifact, but what about the model artifact? Basically the same principles that we just saw for the dataset artifacts apply to the model artifacts. But let's look at an example. So here I'm going to start a run, and this time I'm going to label it as training. I'm going to use the latest clean data artifact that we just stored. I'm going to download that artifact to my local computer and then read it in by passing the path into this string like this. Now I'm going to split our data into the features and labels and then create training and test data out of it. Now here I'm going to train a random forest classifier and log the accuracy. And then finally, I'm going to use joblib to save our model to our local computer, create an artifact, but this time with the type of model, add the file for our model to the artifact, and then log the artifact. You can see how that looks really similar to the dataset artifacts that we just saw. Let's run this. And now let's jump over to the UI and see how it looks different from the dataset artifacts. So you can see right here under model that there's our random forest model. Let me click this. Select that, and there we go. You can see a bunch of data about it here. Like this is the data set that it used, and this was the run. Let's click on this run, and let's explore this run a little bit more. So you can see underneath the Artifacts Registry project, I've selected this run. And now let me click on Overview. You can see here's the accuracy that we logged. You can see more information about it up here. And now let me select Artifacts down here. You can see that the input artifact was our clean Titanic data, The output artifact was our model. Okay, so now there's one more thing that I want to show you before we look at a really cool feature called a sweep. In addition to metrics and artifacts, you're also able to log tables. These tables store rows and columns of custom information, basically whatever you want. Let's take a look at the code and see how this might be useful for your projects. So scrolling down for a second, this is where we're going to create the table of values. But let's walk through the code a little bit more closely. Here, I'm starting a new run with the project table. I'm going to use our cleaned Titanic data and download it like this. Now I'm going to split it into the train and test set, and I'm going to use the random forest model that we just trained and load that too. And here, just for fun, I'm going to get the accuracy of the model that we just loaded in. Now for the table. So when creating a table, you need to specify what all the columns are. We're going to store the predicted value, the actual value, and the probability of survival. In the Titanic dataset, Y is whether or not a passenger survived or died. So the probability of survival is the probability of Y being 1. Then we're also going to store some of the other features that we used to make the predictions. So in this for loop here, I'm going to loop over all of the test data and make these predictions and add them to the table. So then we can go to weights and biases and analyze how well it's performing with these different features. And maybe we can identify certain features where it performs worse than other ones. So this code right here gets a row and then creates a prediction, and then gets the predicted probability, and it gets what the true value for that label should be. And then it adds that information to our table, and it loops over all the data and does that. And finally, we call run.log to log our table to the run, and then call wandb.finish to end the run. Now let's run it. And now let's go to the UI. I'm gonna scroll up, go to projects, click on table, and here you can see that table that we just created. So for example, the probability of survival here is really low, 0.09, which makes sense because it predicted 0 and the true value was 0. Now we're going to look at what I thought was one of the coolest features of weights and biases. If you're familiar with grid search and scikit-learn, then this will look very familiar to you. Weights and biases has a feature called a sweep that lets you use different combinations of parameters to do a bunch of different experiments. And it can all be done with a single click of a button. Let's see what that looks like. So here I'm defining the main function that's going to represent a single run. But let's scroll down a little bit more and see what the sweep looks like. When creating a sweep, you need to define a sweep config. This tells the sweep what to do. I set the method to be random, which means it's going to randomly choose different combinations of parameters. Down here, you can see the parameters. So maybe the first time it will use 32, SGD, and 10, and some learning rate between these. And the next time it will randomly select different values for all of those parameters. And then up here, I specified that it should be trying to minimize the test loss. Now that we've created the sweep config, we can pass it in here to wandb.sweep to define our sweep. I'm also specifying that I want it to be created in a new project called sweep. And now that we define the sweep, it's going to return a sweep ID that we then can tell wandb to run. So you do that by calling wandb.agent and then passing in the sweep ID. And here I'm specifying the function that I want it to call for each run, which, like I said earlier, I defined above here. Now let's quickly go through this function. The first thing it's going to do is start a run and then read in the config. Then I'm going to load up our cleaned Titanic dataset and split it into the training and testing sets. And then I'm going to convert those into PyTorch tensors here. Then I'll define a simple neural network and define the loss function. Now, if you remember, the optimizer was one of our parameters that we want to be randomly selected during each sweep. So what I'm doing here is I'm checking our config and saying if the optimizer is equal to Atom, then use the Atom optimizer. Otherwise, use stochastic gradient descent. Scrolling up for a second, I also forgot to show you that here we're passing in batch size because that's also one of the parameters that we made configurable. Going back down, here's our training and test loop where we're passing in the optimizer with the learning rate that I got from the config too. For each epoch, we're going to log the training loss and test loss and then call finish. So now you can see how we're using this sweep config to loop over all these different combinations of parameters and how we're specifying them in each run. Let's run this code and really see how powerful it is. One more thing I want to mention is that when you specify a method of random, this code will run indefinitely. So I'm going to let it run for a little bit and then I'll kill it after it's completed a bunch of runs. Okay, that's enough. Let me stop this. And now let's go back over to the UI. Let me scroll up, go to projects and select our sweep project. Now let me click on runs. There we go. You can see all of our runs here. So it did about 8 of them. Now let's figure out which run performed the best. Let's go to sort and we want to look at test loss, which you can see right there. And we want the smallest to be at the top. Okay, now let's scroll over and you can see that this run here had the smallest test loss out of all of them. So you can see that it used the Atom Optimizer, 15 epochs, learning rate of 0.05, and a batch size of 32. Let's go back to the workspace for a second. I really like how you can see all of the different runs overlaid on each other here. This makes it really visually clear that this one performed the best. Let's click into this one and look at it a little bit more closely really quick. Here's the training loss and test loss charts. Click on overview. You can see here are the config parameters for the run, those metrics again, and then going over to artifacts, you can see it used the clean Titanic dataset as its input. You just saw how you can use weights and biases to track experiments in a Google Colab notebook. But not all projects are in a single notebook. Many projects use several notebooks managed by different teams, and sometimes they don't even use notebooks at all. They just use scripts. Check out the video on the screen to break out of notebooks and see what a project like that might look like. This will also give you some intuition about how you can use weights and biases in a project like that. Thanks for watching, and I'll see you in the next video.